Welcome to The Explainer, where we turn complex topics into clear, dynamic presentations. So let's start with a puzzle. Maybe you've seen this yourself. You're looking at a money market fund, something like UA Ball, and you see the 7-day annualized return. But then you do a quick calculation based on what you earned yesterday and, you get a lower number. So what gives? Is the platform pulling a fast one, or is there something else at play here?
All right, so today we're going to solve that little mystery, but we're also going to do way more than that. We're going to dive into the core ideas of how money really works over time. We'll hit these 5 key areas, and by the end, you'll have a whole new toolkit for thinking about finance.
Okay, first up, let's get right to it. What's the secret behind that number discrepancy?
And the answer? It all comes down to the difference between simple interest and something way, way more powerful: compound interest. Simple interest is, well, simple. It's calculated only on the money you first put in. Think of it as straight-line linear growth. But compound interest, that's a whole different beast. As they say, it's interest rolling on interest. It means your interest starts earning its own interest. And that, my friends, is where you get that explosive, exponential growth.
All right, so now we know what it is. Let's talk about the how. How do we actually calculate this? We need a formula to see this power in action. And here it is, the compound interest formula. Honestly, this little thing is like the engine of financial planning. It's what lets us calculate the future value, or F, of an investment. In other words, it tells us exactly what our money is going to be worth down the road. Let's break it down real quick. P is your present value. That's the cash you start with. So let's say you invest $1 million. I is the interest rate for each period. We'll use 10% a year, or 0.1. And N is just the number of periods. In this case, 3 years. Simple enough, right? So you run those numbers through the formula. And what do you get? After 3 years, you don't just have $1.3 million. I mean, that would be simple interest. Nope. You have $1,331,000. That extra 31 grand, that's it. That's the magic. That's the interest that you earned on your interest.
And this brings us right back to our original puzzle with the money market fund. If you apply this same compounding logic, but you do it daily instead of yearly, guess what? The math spits out a 7-day annualized rate of, you guessed it, 2.903%. It matches perfectly. The whole secret was just how often they were compounding.
Okay, so this formula is awesome for looking forward. But what's really cool is that you can also use it to look backward and understand what happened in the past. Take a look at this real-world example. Someone buys a property back in 1995 for $1.5 million. Then, 18 years later, in 2013, they sell it for $9.3 million. Pretty nice profit.
But here's the question. What was the actual annualized return on that? You know the beginning and the end, but what did that work out to year after year on average? How do you calculate that?
Well, you just take our trusty formula and you just rearrange it a bit. You solve for I, the interest rate. And when you do that for this property, you find out it delivered a return of 10.46%. That's a really solid return. Every single year for 18 years straight.
Okay, so mastering compounding is a game changer, for sure. But it also opens up a new, trickier problem. How do you compare totally different kinds of investments? When the money comes in at different times. So check this out. Imagine you've got $1 million to invest, and you have to pick one of these 3 options. Project 3, that's our 10% compound interest example from before. But look at projects 1 and 2. They pay out different amounts of cash each year. How in the world are you supposed to compare these? It's like comparing apples and oranges and, I don't know, a big pile of cash that shows up later. To figure this out, we actually have to flip our whole approach on its head. Instead of asking what money will be worth in the future, we need to ask, what is that future money worth to me right now, today? And here's the absolute key idea. $1 today is worth more than $1 tomorrow. Why? It's simple, really, because you can take that dollar you have today, invest it, and it can start earning you more money. If you have to wait for that dollar, you lose that chance to earn. That's what economists call opportunity cost. So this leads to a really brilliant, almost obvious thought. If our compounding formula can take today's money and tell us its future value, what happens if we just run the formula backwards? Can we take a future amount of money and figure out its value today? And yep, that's exactly what this does. We call it the discounting formula. But as you can see, it's really just the compound interest formula flipped around. We're still solving for P, the present value, but this time we're starting with a future amount, F. And that interest rate, I, now gets a slightly different name. We call it the discount rate. All right, now we have our second key tool. Let's put it to work. Let's go back to those 3 projects and finally figure out which one is the best bet. Okay, so here's how we're going to do it. First, we need a baseline to compare against, so let's use a discount rate of 10%, the same return as Project 3. Next, for the other projects, we'll take every single one of those future cash payments and use our new formula to pull them back to today's value. Then, we just add up all those present values for each project. This gives us something called the net present value, or NPV. The highest NPV wins.
And boom, when we actually do the math and chart the NPV for each project, the answer just jumps right out at you. You can see our benchmark, Project 3, comes in at exactly $1 million, just as you'd expect. But look at the other 2. Project 1 is clearly higher, and Project 2 is a bit lower.
So what does this actually mean? It means that even after accounting for our 10% opportunity cost, Project 1 still comes out ahead. Its future earnings are worth over $1 million today. It creates an extra $33,800 in value. Project 2, on the other hand, doesn't even meet our 10% benchmark. Its future earnings are worth less than our initial investment in today's money. So the winner, hands down, is Project 1.
So there you have it. We started with what seemed like a simple math puzzle, and it led us to the 2 fundamental formulas for understanding the time value of money: compounding, which looks forward, and discounting, which looks backward. They're 2 sides of the same coin, and now you have them in your toolkit. As they say, the formulas are ready. All that's missing is the principle and the projects.